Okay, we're going to go through an exponents and surds criteria A formative. Okay, so we're going to begin by having a look at the following questions. If you haven't already had a go at this, please pause the video and write them down and see where you're at, and then we can reflect together. But I'm just going to work through these questions right now. Okay, so let's begin with. So when we are simplifying, so we've got index laws for our first question here. When we are multiplying, we need to add the powers. So this becomes a to the power of 8. Moving across to our next question, simplifying surds. So this one is going to become 5 because we know that 5 times 5 gives us 25. So we've got 10 times 5. This bit is being multiplied. So the answer is 50. Moving on to the next one. Simplifying. When we have exponents like this, remember this is the same as y to the negative 3 times y to the negative 3, y to the negative 3 times y to the negative 3 times y to the negative 3. Instead of writing it out, because we know to add all of these, a slightly quicker way of doing it would just be to times these when we have a bracket. So it becomes y to the negative 15. Simplifying a surd, so we have root 20 here to simplify. Let's think about our square numbers. Which one of these goes into it? So we have root 20 can be split up into root 4 and root 5. That becomes 2 root 5 because the square root of 4 is 2. Next question. When with surds, if we are multiplying or dividing, we just follow the same rules. So because these both have a surd, these both are a surd, we are simply going to be able to do root 22 over 11. We can bring them all inside the same surd, which becomes root 2, because 22 divided by 11. And the next one we have here is zeros and dividing, so 0 power, and dividing when we have index laws. So anything to the power 0 is always a specific number. If we think about it logically, 2 squared is 4, 2 to the 1 is 2, 2 to the 0. Well, as we move down our powers, we are dividing by 2, and we get 1, 2 divided by 2. Same thing works if we did 7 squared, which is 49. 7 to the 1 is 7. We are dividing by 7. So it always becomes 1 because we're dividing by 7. So our first answer is 1. Anything to the power 0 gives us 1. Now, if we're dividing, think back to when we were multiplying in question 1. We added the powers. When we are dividing, we simply subtract the powers. Because in theory, if we wrote out this k times k times k times k, etc., we went on and on, divided by k times k times k times k, and we had 13 on the top and 4 on the bottom, we know that 4 of these would cancel, and we would be left with k to the 11, which is the same as doing k to the 13 and divided by k to the 4, k to the 11. We have subtracted them. Okay, so double check your answers here and see if there's any areas of strength and any areas of development. Okay, moving on to the next section. Feel free to pause the video and work through these and then use it as a reflection tool. Okay, next section, we have to simplify the following question. So whenever we have these numbers in front, the coefficients, we have to multiply them together. So we're going to get 30. And then think about your index laws. So u and u to the 3. This is u to the 1. So it becomes u to the 4 because we add them together. And then we just have r. R does not have any other similar terms. So it just becomes r to the 3. That is simplified. It's a simpler version than the question. Okay, the next one, we have a couple of ways of doing this, but let's always double check. Does this simplify in the way before? Could we make this root 50 over 2, which becomes root 25, which actually becomes 5. So we have 5 plus the square root of 100. Square root of 100 is 10. 5 plus 10 equals 15. Now, when we're adding and subtracting surds, it's very similar to doing 15y plus 40y. That would become 55y, like we're adding algebra. When we are adding with surds, and they're the same surd, very important, we are going to have 55 root 7. So we just add the coefficients, and the surd is the same, so we just put it together. And for this one here, whenever we have a fractional power, it actually means the root. Okay, so if you have a to the 1 over n, it's the same as n root a. What that actually means is if we have a power of a half, we're doing the square root. If we have a power of a third, we are doing the cube root, and so on and so forth. So here we have the square root of 25, which is going to be 5. Okay, moving on to the next questions. We have a couple more questions down here. So pause the video, have a go at the questions, and then just check your answers. Okay, so the first question here, we have to expand and then simplify if we can. Let's see. So 5 times root 2 is going to give us 5 root 2. 5 root 20 is going to give us plus 5 root 20. Now let's just take a side note and think root 20 is the same as root 4 times root 5, which is the same as 2 root 5. Let's put that back into our question. So we have 5 root 2, add 5 times 2 root 5. Okay, now I'm just going to erase this section. This is going to turn into 5 root 2. Now let's look here. What's going to happen here? This is going to become 10 root 5. That is our final answer. So I'm just going to write it up here so it's clear. 5 root 2 plus 10 root 5. Need a little bit more space. Now, moving on to the next question, we have to simplify this one. Now, we know from the earlier question that a power of a half means square root. Because the whole fraction is in the bracket, we are square rooting each term on the bracket. So we're effectively doing the square root of 9, square root of 49 equals 3 over 7. Square root of both values. Now, for the next question, we're looking at negative powers. Now, negative powers become a fraction. We know that if we have a to the negative m, that's the same as 1 over a to the m, because it comes down to the power, the denominator. The power controls whether it's going to be a whole number or a fraction. Let's have a look here. We're going to turn this into 1 over 9 to the 1. 9 to the 1 is just 9, so we don't need that 1. Same thing as if we had 9 to the negative 2, it would be 1 over 9 squared, which would be 1 over 81. So we can use that power to go down with the denominator and then simply solve. Next one, rationalizing the denominator. So when we rationalize, our method is to multiply by something that equals 1. So root 3 over root 3 equals 1, but can also cancel out at the bottom. And when I mean cancel out, what's going to happen here is now I get root 3 on the top because I'm doing 1 times root 3. And on the bottom, I'm going to have root 3 times root 3, which is just root 9. Now the goal is to have a rational number on the bottom. So I would have 3 on the bottom. A rational number is a number that's not a surd. So that is it. Okay, moving on. So the next questions here, we're going to have a look at some slightly more complex, but using a lot of the skills we had before. So if you haven't done this already, just pause the video, have a go, and then come back to the video. Just remember that a half means square root. Okay. Now, when we have brackets, we also times the powers. So what's really important here is that we have 36 to the half. Then we have a 6 to the half. then we have v10 to the half. I've written it out like this to try to help me because I've split all three terms up. 36 to the half is just the root, so I've got 6. Then I'm going to times these two together. So I have a to the 3, because 6 times a half is just 3, half of 6. And then over here, I'm going to do 10 times a half is 5, so b to the 5. And that's it. That's as simplified as it can be. Next one here, we're going to expand the bracket. So I have root 6 times root 3, which is root 18. And then I have root 6 times root 6, which is root 36. I know root 18 is going to simplify to be root 9 root 2, which is 3 root 2. And I know root 36 is actually just 6. So my answer is 3 root 2 plus 6. Okay, moving down to the next ones. Remember, this can be split up. This is the same as doing 8 to the 3rd, then squared, if we take that numerator out. So 8 to the 3rd squared. 8 to the 3rd is equal to 2, because it's a cube root. 2 squared equals 4 as a final answer. Next one, we're looking at dividing. Now, what we want to do here is we want to think about each term. We are dividing, so we subtract the powers. Okay, so for the p, we're going to do 4 minus 4, so we get p to the 0. P to the 0 is actually just 1, so we don't need to write it. For the y's, we have y cubed and y to the negative 3. Be mindful we are dividing, so y cubed divided by y to the minus 3, and we are subtracting the powers. So we are doing 3 subtract minus 3. What happens there? It becomes a plus, because when you subtract a negative, you're taking away an ice cube. You're taking away something negative that actually becomes warmer. If you take an ice cube out of your drink, it gets warmer. So now we're going to get y to the 6 with no p-value because these two equal 1, so we don't need to write it. Okay, there's 2 more questions just down here, so pause the video if you haven't had a go with them yet, and then I'll just go through them. Okay, now, touched on it before that when we have a negative power, it sometimes becomes 1 over something. What's interesting is when we have a fraction, we use the reciprocal. So actually we were always using the reciprocal because 2 and a half is a reciprocal, because we think 2 is secretly 2 over 1. So we don't always write 2 over 1, but that's effectively what we've done. And it becomes this, it becomes 1 over 2. Now, if we have a fraction, the negative power makes it flip. So if we look at the negative, that makes it become 8 over 27. We lose the negative to the 3rd because it's flipped the fraction. Then a 3rd means cube root. So we're doing the cube root of 8 over the cube root of 27. Okay, what times by itself 3 times to make 8? We get 2. What times by itself 3 times to make 27? We get 3. That is the answer. And for the last one here, we have to rationalize the denominator. So again, we're going to times it by root 11 over root 11 because it has to equal 1, and it's also to do with this denominator. That becomes 22 root 11 over root 11 times root 11, which is root 121, but you want to start to get into the habit of seeing that this equals 11. So I'm going to write this in a clearer way, over 11, because root 11 times root 11 is equal to root 121 on the bottom, but this one always simplifies. So we're going to have 22 root 11 over 11. Then look at our coefficients. 22 divided by 11. 22 divided by 11 is just 2, so we get 2 root 11. There is technically a 1 on the bottom, but let's not write that because we know that we do not need it. Hope this helps.